In this video, we're going to learn about and how to use the Pythagorean Theorem. Now, if you're a student who doesn't go to Ridgewood High School and watches these videos but does not have me as a teacher, that right there is a picture of me. It was taken a couple weeks ago, so if you're curious about what I look like, that is exactly what I look like. Now, before we get into the Pythagorean Theorem, you need to learn about, or a little bit about, the anatomy of a right triangle. So, a right triangle, as you know, is a triangle with one of the angles being 90 degrees. Now, the side opposite the 90-degree angle is the largest side, and that's called the hypotenuse. So you first locate the hypotenuse by looking for the little box which indicates an angle is 90 degrees. The side opposite that, right across from it, is the hypotenuse. The two other sides, the sides opposite the acute angles, see this angle right here is acute, this angle right here is acute, are called the legs. Alright? So, when you hear of hypotenuse and leg, you need to know what I'm talking about. Another way right triangles are commonly labeled are by naming the legs A or B and naming the hypotenuse C. Now, the hypotenuse always has to be C. So, if you see a leg or a side length of a triangle called C, that has to be the side opposite the 90-degree angle. A or B could be interchangeable. A or B just indicates that it's one of the legs, one of the sides opposite the acute angle. So it doesn't really matter which leg you call A or B, as long as you're naming a leg A or B, and not C. And the Pythagorean Theorem is as stated right there. It says that A squared plus B squared equals C squared, which means that the square of the sum of the two legs is equal to the square of the hypotenuse. Now in class, we're going to prove that, and this picture right here is the best I can really do over a video to kind of prove to you why it works. So in words, the Pythagorean Theorem says, in a right triangle, the sum of the squares of the length of the legs equals the square of the length of the hypotenuse. So right here, that I'm highlighting with my pen, are the legs. And if we square the legs, they'll have an area of these two squares. Now, the sum of the squares of the legs should equal the square of the hypotenuse. So this biggest square represents the square of the hypotenuse. So if you look at the picture, and if you cut up the smaller square into those green pieces and the medium square into the blue pieces, you could fit those pieces into the bigger square. So like notice how this little green piece fits perfectly right here, and this blue piece fits perfectly right here. So it's just a little visualization proof of why it works. And again, in class we'll do a more hands-on proof, but that's just a little something to hold you over. Now, let's apply the Pythagorean Theorem. So whenever you do a Pythagorean Theorem problem, until you have this memorized, you should write down the Pythagorean Theorem. A squared plus B squared equals C squared. And it's pretty easy. Next, you plug and chug. You look for what numbers go in for A, B, or C, and then you solve for the unknown variable. So the side lengths that are 3 centimeters and 4 centimeters are opposite the acute angles. Alright, and this is a poor problem on my part. I should have added this little right triangle notation right here with the box. So if that's not there, you shouldn't assume that that angle is 90, but just bear with me for this example. So I'll put it on the other one so we got it ready. So I'm going to plug 3 in for A and 4 in for B. And I could have done that the other way. It doesn't really matter as long as you're plugging in the legs for A and B. What does matter is that X must be C. So again, 3 or 4 could be A or B, doesn't matter which one's which, but X has to be C because X is opposite the side that's 90 degrees. So that's the hypotenuse. So now we're going to solve for X. So by adding 3 squared and 4 squared, which is 9 and 16 respectively, we get 25. So we get that X squared is 25. So X, the inverse of squaring something, that'll help us cancel out that X, that squared in the X squared by taking the square root. X is just going to be 5. And if 25 wasn't a perfect square, you would simplify the radical like we did in the previous video. So that side length was 5. Let's try it again. Now we're given C, and we're also given one of the legs. Oops, I don't know why that happened. Let's try that again. So we're given C, the hypotenuse, and we're given one of the legs. Come on. Okay, sorry. little technical difficulties. This app could be really annoying sometimes. Alright, my bad. So that leg 12 is A. This leg right here we could call B. And again, A and B are interchangeable as long as they're the legs. So now we're just going to solve for B instead of C. So we got A squared plus B squared equals C squared. He said A was 12. So we got 12 squared plus Y squared, which is the other missing leg, is equal to 13 squared. So now we're going to get Y alone by doing reverse PEMDAS. So first, square all these numbers. So we have 144 plus Y squared equals 169. We're going to subtract 144 on both sides. And we get Y squared equals 25. And now, if we know Y squared is 25, to get Y alone, we're going to take the square root. So the square root of Y squared is Y. The square root of 25 is 5. So that's our answer. Alright, those were two pretty straightforward Pythagorean Theorem problems. So we just want to try two more, slightly more complicated problems. So if you want to try this one on your own real quick, pause it and then hit play when you want to see the answer. Go for it. So, right here we have a square. We know it's a square because all the sides are equal, and since that one angle is 90 degrees, we can prove that it's a parallelogram and all the angles have to be 90 degrees. So any square, if you draw the diagonal, is going to be divided into two isosceles right triangles, which means that it has two legs that are congruent, an angle that's 90, and, well, that's all that really means. So, since it's a square, and we know that this side length is x, we know that all the side lengths are x. Now, if we focus in on this right triangle, we can express x and 4 radical 2 using the Pythagorean theorem. So first let me write it down. A squared plus b squared equals c squared. I'm going to say a is x, I'm going to also say b is x, and 4 root 2 is c. So by plugging those into the Pythagorean theorem, I have x squared plus x squared equals c squared. So I'm squaring c entirely, so I have to square 4 root 2. So I'm going to put 4 root 2 in parentheses and square the whole thing. A common mistake I see is that students will only square the root 2. We have to square the entire hypotenuse, which is 4 root 2. Alright, now to solve. Well, I have right here x squared and x squared. Those are like terms, so I can combine them and rewrite it as 2x squared. 4 root 2 is going to equal 4 squared times root 2 squared. Alright, well 4 squared is 16, root 2 squared is 2, so 16 times 2 is 32. And then on the left side I still have 2x squared. So to get x squared alone, I'm going to first divide by 2. So I get x squared is 16, and then take the square root. Now you might be thinking, well the square root of x squared could be 4 or negative 4. And if you think that, you are right. Good thing to think. But we're talking about lengths of a side of a triangle, and lengths can't be negative since it's a magnitude. So we're just going to only take the positive answer. So our answer is x equals 4. And you can always plug it back into the Pythagorean theorem and make sure that it works. Alright, one more problem, which is slightly more challenging, is this one right here. So again, if you want to try it on your own, and then hit play to see the answer, go for it. So, let's go over this one. Now, notice we have looks like some sort of rectangle right here, where it has a base of 5 and a height of 4 root 3, and we have a right triangle right here. So if I redraw this right triangle, because we're gonna, since this is the Pythagorean theorem video, there's a good chance we need to use the Pythagorean theorem. I want to focus on this right triangle and try to come up with an equation with x in it. So I have this hypotenuse right here is x. And since this entire base is 17, and from here to here is 5, then this leg of the right triangle from this point to this point would have to be 12 in order for this picture to make sense. And this height of the right triangle right here, well, since these angles are all 90 degrees, we know that this green leg and this green leg both have to be congruent. So this leg right here is 4 root 3. So now, let's use those values and plug them into the Pythagorean theorem. So I have a squared plus b squared equals c squared. So this hypotenuse is c. I could call this 4 root 3a and 12b. So when I plug everything in, I have 4 root 3 in parentheses squared plus 12 squared equals x squared. Alright, 4 root 3 squared is equal to 4 squared times root 3 squared, plus 12 squared, which is equal to 144, equals x squared. 4 squared is 16, and then we still have to multiply it by root 3 squared, which is just 3. So we have 16 times 3, plus 144 equals x squared. 16 times 3 is 48, plus 144 equals x squared. So now I'm going to combine like terms. So 48 plus 144 is 192 equals x squared. Now I'm going to take the square root of both sides and just change the color because it's just getting a little messy. So we have x is equal to the square root of 192. Now, hopefully you realize that that could be simplified. So after some thought, you should see that there is a perfect square that goes into 192. And there's actually a few of them, 4, 16, but the biggest one is 64. So we want to rewrite the square root of 192 as the square root of 64 times the square root of 3, because 64 times 3 is equal to 192. So the square root of 64 is 8 times square root of 3, which is square root of 3, and boom, that's our answer, 8 root 3. So, I hope this video was helpful. Refer back to it if you need more practice with Pythagorean theorems or radicals. And that's about it. Email me if you have questions, and have a good one.